Okay, let us start our discussion about the signal transmission and the channel bandwidth. So, to understand what band is allocated, we must understand how that broadcasting channels are occupied, or what band they occupies. So, the first thing that whenever I'm talking about the television, for the television broadcasting channels have been assigned the VHF and a UHF range. So, if I talk about the VHF range, my VHF range is from 30 megahertz to 300 megahertz. ठीक है, and UHF range, if I talk about this range, it is from 300 megahertz to 3 gigahertz. ठीक है, so this is the band which is given for television broadcasting. Now the allocated frequencies are, say if I'm talking about the lower VHF band, my VHF band starts from 30 megahertz to 300 megahertz. ठीक है, तो आपका lower VHF band जो भी है वो 41 to 68 megahertz है. So this is called as the band 1. Your band 3 is 174 to 230 megahertz. Now we just make a mention over here that band 2 is not used for television transmission. For what purpose it is used, that will separately discuss. Band 4 is from 470 to 582. 470 is not in the VHF range. So we can say this is the UHF range, which is having a band 4. Then band 5. So band 5 is used for 606 megahertz to 790 megahertz. Now here one band is missing, that is nothing but the band 2. So here if you do recall that 88 to 108 megahertz is allocated for FM broadcasting. If you are having a FM in your radio, you just see the frequencies allocated for that FM radio. So FM radio is transmitted in this particular band from 88 to 108 megahertz, and that's why this band is not used for television transmission. So band 1, band 3 are used for television transmission, band 2 is for radio transmission. So you can see the channel allocation in band 1 and 3 are given below. So here I have one separate table, whereas you can see how that allocation takes place. So here you can see your channel or your band range is 141 to 68 megahertz. I have already explained you what is the one video bandwidth in the previous session. So what is the video bandwidth? If I talk about the video, only video bandwidth is a 5 megahertz. If I talk about one channel bandwidth, because my one channel completely, or it will have a audio plus video, so it's a 7 megahertz. So for each and every channel I must assign a 7 megahertz of a bandwidth. So in the band 1, 41 to 47, so this is not a 7 megahertz, this is a 6 megahertz. It is not used for any transmission. It is just used for the research purpose, or if you want to do any research in this particular range you can do it. ठीक है, but this is licensed. 47 to 54, this is 7 megahertz. Channel 2, channel 3, 54 plus 7, 61, 61 plus 7, 68. So these four channels are there. Out of that, channel 1 is not in used. Now picture carrier and sound carrier, I'm not going to tell you right now because it needs some explanation why picture carriers is to that frequency only. So I'll explain these things afterwards. Okay, so this is everything about the band range 1. This is a VHF band 1. VHF band 3 is from 174 to 223 megahertz. 174 to 181, you just add 7 megahertz. आपके 4 चैनल्स बैंड 1 में जा रहे हैं, बैंड 3 में आपका 5th चैनल गया. ये बैंड स्टार्ट हो रहा है 174 से, so 174 plus 7 it is 181. 181 plus 7, 188. You simply add 7 megahertz in each frequency, you'll get the next channel. ठीक है, such 10, or you can say 5, 6, 7, 8, 9, 10, such 6 channels are transmitted in the band 3. There are some additional channels also, that is 11 and 12, 216.23 and 223.23. ठीक है, so these are nothing but the some additional channels, whereas they have given. Now you need to like I think there is like 216 से अगर start हो रहा है तो वो 223 तक जाएगा यहाँ पे. So I will just make a correction, it's 223, और 223 से अगर वो start हो रहा है तो 223 plus 7 it's 230 megahertz. So this is the 7 megahertz bandwidth over here and 7 megahertz bandwidth. You don't bother about these figures right now. I'm going to explain you why picture carrier is not at 47 and why it is 1 plus point. Like if you see here 47 से आपका channel start हो रहा है, लेकिन आपका picture carrier जो है वो 1.25 away from your starting point. Why it is that way it is written, I'll explain you afterwards. You right now just understand that one channel bandwidth is a 7 megahertz. Now I'm going to discuss why 7 megahertz. Okay. Now CCIRB standard, this is just the revision what we have seen in the previous session. Video characteristics. How many numbers are there per picture? 625 lines. Okay. So number of lines per picture are 625 lines. How many pictures you are transmitting in one frame? you're having a one frame but you are using a interlace scanning. तो आप इसको डिवाइड कर रहे हो दो फील्ड्स में, एक होता है आपका ऑड फील्ड और दूसरा होता है आपका इवन फील्ड. सो द वन frame is divided into two pictures and that's why interlace ratio is 2:1. अगर आप एक पिक्चर एक साथ में स्कैन कर रहे हो it will be progressive scanning and your ratio will be 1:1. If you are dividing that one picture into two fields and that two fields are separately scanned, it will be called as a 2:1 interlace ratio. Next one is nothing but the scanning sequence. आपका scanning sequence कहाँ से कहाँ होता है? It is left to right. Then again it comes back left to right. Next is scanning sequence for फील्ड. ये लाइन टू लाइन स्कैनिंग सीक्वेंस है लेफ्ट टू राइट. व्हाट अबाउट फील्ड फ्रॉम टॉप टू बॉटम? ठीक है, आपका स्कैनिंग कैसे होता है? टॉप टू बॉटम, रिट्रेस बॉटम टू टॉप है, स्कैनिंग टॉप टू बॉटम ही होता है. ठीक है. सो फील्ड फ्रीक्वेंसी, हाउ मेनी फील्ड्स आर देयर? 50 फील्ड्स पर सेकेंड. That's why your field frequency is 50 hertz. What is the line frequency? How many lines are there? 625 lines. How many fields are there? You can say, or how many frames are there? 25 frames. So your frequency is 15625 hertz. So this will be the line frequency or horizontal scanning frequency. Aspect ratio, we are talking right now about the standard television. Okay, that's why it is 4:3. Now video bandwidth 5 megahertz. Vertical resolution, you need to consider the scale factor over here, that is zero point 0.7 into how many lines are there? 625 lines. How many lines get wasted during a vertical retrace? 20 lines each field. So total lines आपके कितने waste हो जाते हैं vertical retrace में? 40 lines. So that's why you need to subtract that 40 lines. So vertical resolution is 409 lines. What about the horizontal resolution? In this you just take that active or that vertical resolution VR line that is near about 401 or 410 into aspect ratio. You need to consider this aspect ratio which is 4:3. That's why 4/3. So what is the horizontal resolution? It's 546 lines. Okay, so this is your horizontal resolution. The next is nothing but the how this is the alternate black and white. We are right now talking only about the monochrome television. Then we have discussed about the composite video signal. So if we see the details of composite video signal, एक लाइन का पीरियड होता है 64 माइक्रोसेकंड, blanking period 12 microsecond, and this blanking period is again divided into front portion, back portion and then into the sync. So total मिला के आपका 12 microsecond हो जाता है. Front portion is 1.5 microsecond, your synchronizing pulse is 4.7 microsecond and your back pulse duration is 5.8 microsecond. Now here we need to put some pre-equalizing and post-equalizing. This is all about the line period. Now here I am talking about the vertical blanking. So आपका जो भी प्री और पोस्ट इक्वलाइजिंग पल्सेस होते हैं 160 माइक्रोसेकंड के होते हैं. इन वर्टिकल trace also you are having vertical sync you are also having a 160 microsecond, means 2.5 horizontal line each. Total vertical blanking period कितना है होता है आपका 1.280 microsecond. This means 1.280 millisecond. फील्ड पीरियड 20 मिलीसेकंड टोटल. तो ये आपका हो गया रिट्रेस पीरियड, और ट्रेस पीरियड जो होता है आपका 18.720 मिलीसेकंड होता है. सिंक लेवल इज 100%, ब्लैंकिंग लेवल इज 75% एंड वाइट लेवल इज नियर अबाउट 10 to 12.5%. In some of the books you will find it is 10%, in some of the books you will find it 12.5%. ठीक है, both are correct. So radio frequency characteristics. अभी हम radio frequency the complete channel bandwidth I'll consider here. So my channel bandwidth is 7 megahertz, which includes audio plus video. ठीक है. Sound to picture carrier difference. This is 5.5 megahertz. ठीक है. I'm going to explain this one, but you right now remember it's 5.5 megahertz. What is the picture modulation? It's amplitude modulation, vestigial sideband transmission. Which type of modulation you are using for picture? Amplitude modulation. Which type of modulation you are using for audio signal? It's a frequency modulation. So if you are doing a frequency modulation में आप क्या करते हो? This is your modulating signal. This is your carrier frequency. Higher frequency is always a carrier frequency, and there is a deviation in the frequency. ठीक है? ऐसे डेविएशंस होते हैं, वो डेविएशंस कितने, इफ दिस इज द कैरियर फ्रीक्वेंसी, योर डेविएशंस आर प्लस माइनस डेल्टा एफ, सो हाउ मच डेविएशंस आर अलाउड, plus minus 50 kilohertz. This is for television, huh? We are talking about the TV. So for TV, plus minus delta f is equal to plus minus 50 kilohertz. For radio it will be 75 kilohertz. What is the pre-emphasis at 50 microsecond? What is the color subcarrier frequency? You just remember right now, then we are going to discuss why 4.43. ठीक है, color subcarrier frequency is 4.43 megahertz. Which type of propagation you are using? It's a space wave propagation. And then which type of polarization? It's horizontal polarization. So these are the details. Now here, whenever we are talking about the modulation, or whenever we are talking about the sending your signal as it is, you are, you can't transmit, or it's impossible to transmit a signal by itself. The greatest difficulty using unmodulated wave, you waves are, you need a long antennas. Okay, so suppose I'm using some frequency like 20 kilohertz, so what will be my antenna height? So it will be lambda by 4. अगर आपका frequency कम है तो आपका wavelength, because I know that my frequency is equal to c by lambda. So as frequency increases, lambda decreases, or as frequency decreases, lambda increases. So for lower frequencies I need a more heighted or more size antenna. So that's the one thing why we are going for the modulation. And another important reason for not transmitting signal directly, that both picture and sound signals from different stations are concentrated within the same range of frequencies. Okay, so therefore radiation from different stations would be hopelessly, and you can say they will mix up, and it would be impossible to separate one from the other at the receiving end. So thus, in order to be able to separate the intelligence from different stations, it is necessary to translate them all to different portions of the election. And that's why whatever carrier frequencies you are assigning, that must be separate over there. Okay, so this is the reason why we are modulating the signal. Now we'll talk why frequency modulation is for audio and why amplitude modulation is for video. We can do uh, अपोजिट ऑल्सो, हम लोग एम्पलीट्यूड मॉड्यूलेशन ऑडियो के लिए यूज कर सकते थे, फ्रीक्वेंसी मॉड्यूलेशन वीडियो के लिए, लेकिन हम लोग वी आर यूजिंग फ्रीक्वेंसी मॉड्यूलेशन. सो व्हाई? The first reason is because of crowding in the medium and short wave bands in the radio transmission. The highest modulating audio frequency used is the 5 kilohertz, and not the full audio range, which extends up to about 15 kilohertz. Though we are talking that our audio range varies from 20 hertz to 20 kilohertz, you're modulating, अगर आप आपका normal audio लेंगे तो its frequencies इन बिटवीन दिस रेंज 3 to 5 किलोहर्ट्ज. ठीक है, सो वो पूरा का पूरा 15 किलोहर्ट्ज तक कभी भी यूज नहीं किया जाता. ठीक है, नेक्स्ट, दिस लिमिट ऑफ हाईएस्ट मॉड्यूलेटिंग फ्रीक्वेंसी रिजल्ट्स इन चैनल बैंडविड्थ सेविंग, एंड ओनली अ बैंडविड्थ ऑफ 10 किलोहर्ट्ज इज नीडेड per channel. Next, it will become difficult, or it becomes possible to, or you can say, if you are using the frequency modulation, I can say आपका जो भी modulating frequency है 20 hertz to 20 kilohertz है, अगर आप वीडियो सिग्नल की बात करेंगे उसका modulating frequency 5 megahertz है. ठीक है, so if I'm going for frequency modulation for video signal, I'll require more bandwidth. ठीक है, सो यहाँ पे the same reason is enlisted here. It becomes possible to accommodate large number of radio broadcast stations in the limited broadcast band. अगर मैंने जो मेरा ऑडियो है जिसका मॉड्यूलेटिंग फ्रीक्वेंसी कम है, और नॉर्मली उसके बैंड्स कैसे होते हैं, FC प्लस FM, FC माइनस FM, तो आपका if I say FC carrier frequency plus FM, carrier frequency minus FM, और मैंने 5 kilohertz यूज किया है, what will be my bandwidth? My bandwidth will be FC minus FM plus FC plus FM. So my total bandwidth will be twice FM, that is 10 kilohertz, which is mentioned here. ठीक है, that's why I can send more number of signal. Since most of the sound signal energy is limited to lower audio frequencies, the sound reproduction is quite satisfactory. The next reason is frequency modulation is capable of providing almost noise-free and high fidelity output, needs a wider swing in the frequency on either side of the carrier. If you compare frequency modulation, and if you compare एम्पलीट्यूड मॉड्यूलेशन, जो नॉइज परफॉर्मेंस ऑफ फ्रीक्वेंसी मॉड्यूलेशन इज ऑलवेज better than the you can say amplitude modulation. So as you are more sensitive to the changes in the audio signal, ठीक है, तो वो आपका ऑलमोस्ट क्लियर सिग्नल यहाँ पे देगा. नाउ दिस कैन बी इजीली अलाउड इन द टीवी चैनल where because of high video frequencies a channel bandwidth of 7 megahertz is allotted. ठीक है, अगर आपका ऑलरेडी वीडियो बैंडविड्थ 5 मेगाहर्ट्ज है, आपको अलाउड और कितना होना चाहिए? You are allowed to use up to 7 megahertz, so you can go in that range only. So in FM, where the highest audio frequency allowed is 15 kilohertz, okay, the sideband frequencies do not extend too far and can be easily accommodated around the sound carrier that lies 5.5 megahertz away from the picture carrier. The need is that your picture carrier and your sound carrier must be way apart so that they will not intermix with each other and they will not affect क्वालिटी ऑफ ईच अदर. ठीक है, सो यहाँ पे अगर 5, आपको 7 मेगाहर्ट्ज बैंडविड्थ है, 5 में आपका वीडियो जा रहा है, और आपका अगर 15 किलोहर्ट्ज भी है तो प्लस माइनस 50 किलोहर्ट्ज का डेविएशन आप दे रहे हो, तो उसी बैंड में वो अकोमोडेट हो सकता है. ठीक है, and the bandwidth assigned to FM sound signal is about 200 kilohertz, of which not more than 100 kilohertz is occupied by the sidebands of the significant amplitude. ठीक है, that we'll see when we are going to talk about that bandwidth allocation. So latter figure is only 1.4% of the total channel bandwidth of the 7 megahertz. अगर आप ये 100 kilohertz देखेंगे तो वो 1.4% ही है. Thus, without encroaching much in a relative sense on available band space for television transmission, all the advantages of FM can be availed. So these are the reasons why FM is preferred for audio over AM. Now we'll talk about how your video signal is transmitted. So my video signal here is transmitted like this. So I can say my video signal is amplitude modulated. How you are going to use the amplitude modulation? We need a modulating signal, so I need a modulating signal which is represented by em cos of omega mt. How you are representing your carrier signal? Ec cos of omega ct. And how you are going to represent your modulated wave? It is nothing but the a cos of omega ct. Now here we are going to write each and everything. So my carrier signal here is nothing. I'll write first modulating signal, which is nothing but the em cos of omega mt. What is the carrier? This is ec cos of omega ct, and this is what we called as instantaneous amplitude. ठीक है, और उसके साथ आप cos omega ct. So amplitude modulated, or I can say this my instantaneous amplitude E is equal to, or I can say my this instantaneous amplitude, I can write is say A, ठीक है, and A is equal to EC plus K EM cos of omega mt. So EC is nothing but the amplitude of my carrier wave signal. This is amplitude of carrier wave signal, and KEM, that is EM, my this just K is nothing but the constant. You just remember this K is nothing but the constant. Now what will be my amplitude modulated waveform? Say this is E, which is A cos of omega ct. So A तो आपने पहले से लिखा हुआ है. So I'll just put all these things. I'll just write EAM, that is amplitude modulated waveform, is equal to EC plus KEM cos of omega mt, which is multiplied with the cos of omega ct. Just I have replaced this A with this instantaneous amplitude. Okay. So if I further write this equation, this EC cos of omega ct plus, I'll just put KEM cos of omega mt cos of omega ct. Now I have this equation which is in terms of the cos A cos B. So you know that cos A cos B is equal to 1/2 cos of A plus B. ठीक है, minus 1/2 cos of A minus B. ठीक है. So we have got our equation in that way. Now I'll just write this equation. I just elaborate that whatever amplitude modulated waveform we have got EC cos of omega ct plus 1 half cos of omega c minus omega mt plus 1 half cos of omega c plus omega m and multiplied with the t. ठीक है. Now here, ठीक है. So we have already sorry, I have just forgot here to, here em is there, no, so I need to take that em over there. So I can take here em by 2, em by 2. So this is my equation which I have got. Okay. Now uh, we need to consider here the modulation index. So what is the modulation index here? K em by ec, and this is what we called as the modulation index. Okay. So I want this equation in the terms of modulation index. So I'll just write down this equation once again. Amplitude modulated waveform is EC cos of omega ct plus em by ec. So I can say this, if I put here ec, I need to put here also ec. So I can say mec by 2. Now omega c minus omega m is nothing but a 2 pi fc minus 2 pi fm t plus again m ec, its modulation index, by 2 cos of 2 pi fc plus 2 pi fm t. ठीक है. So now how many frequency components, and this omega c is nothing but the 2 pi fc. ठीक है. So I have got a carrier frequency. How many frequency components I have got in this equation? fc, fc minus fm, fc plus fm. So if I want to represent it into the frequency domain, this is the amplitude modulation and this will be the frequency spectrum. So here I have got this fc which is having a carrier frequency. What will be the amplitude of that fc? The amplitude will be ec. I have got fc minus fm, so this is one component, and its amplitude is mec by 2. So first जो भी है आपका कंपोनेंट वो रिप्रेजेंट करता है आपके वेव के एम्पलीट्यूड को. सो दिस इज mec by 2. What about this? Will be called fc minus fm, will be called as a lower sideband, and fc plus fm will be called as the upper sideband. So what will be the amplitude here? mec by 2. So here I have got three components. So if I want to see what is the bandwidth of this particular amplitude modulated waveform, then I can write my range of frequency in which my signal lies. So fc plus fm minus fc minus fm. So minus minus will become plus. Okay, so this will be the twice of fm. So if I'm interested in calculating the bandwidth, I know what is the video bandwidth, that is 5 megahertz. So this will be 2 into 5 megahertz. So my bandwidth of video signal is totally 10 megahertz. This is the how I can calculate the bandwidth in amplitude modulated signal. So I have got 10 megahertz of a bandwidth. Okay, so this is all about how we are कैलकुलेटिंग दिस थिंग्स. ठीक है. अगर मुझे इसका टोटल पावर निकालना है, इफ आई एम इंटरेस्टेड इन द टोटल पावर, हाउ आई एम गोइंग टू कैलकुलेट टोटल पावर? कैरियर पावर प्लस अपर साइड बैंड पावर प्लस लोअर साइड बैंड पावर. ठीक है. So what will be the carrier power? This is RMS value of that. So carrier का आपका amplitude है EC by, so suppose you are taking it peak, because this amplitude is always a peak, it's not a peak to peak. So EC by root 2 square divided by R. This will be the carrier power. What about the upper sideband and a lower sideband power? Your upper sideband power will be same as the lower sideband power because both are having the same amplitudes. M E C by 2. ये कंप्लीट जो भी है उसका बाय रूट 2 करके आपको स्क्वायर करना है और उसके बाद डिवाइडेड बाय आर करना है. सो इफ आई राइट अ टोटल पावर, आई विल गेट अ टोटल पावर एज अ EC स्क्वायर डिवाइडेड बाय आर प्लस m स्क्वायर EC स्क्वायर. ठीक है. उसके बाद 2 का स्क्वायर हो जाएगा 4 और ये 2 8. सो आई कैन राइट हियर इट्स 8R प्लस m स्क्वायर EC स्क्वायर डिवाइडेड बाय 8R. सो अगर अब 8 अगर आपने ऐड कर दिया तो इट विल बिकम अ, I can say 4R. ठीक है, sorry 8R. It's twice of m square EC square. So this will become this 4R. So if you put EC square by R is equal to your carrier power, then you can say this is m square by 4 PC plus m square by 4 PC. Okay, so this is how we can calculate the total power which is required to transmit that signal. This thing I'm going to explain once again. So this is all about the amplitude modulation. Now how you're going to find out the channel bandwidth? आपका picture carrier यहाँ पे है 0 पे, ठीक है? You're assuming right now that it's not actually zero value, it is some frequency. Let it be, if I'm talking about 47 के रेंज में, 47 to 54 का अगर आप बैंड ले रहे हो तो उसी रेंज में कोई तो वो फ्रिक्वेंसी हो जाएगा आपका. सो राइट नाउ आई एम अज्यूमिंग दैट माई पिक्चर कैरियर इज एट 0 मेगाहर्ट्ज. सो व्हाट इज द बैंडविड्थ रिक्वायर फॉर पिक्चर? इट्स अ 5 मेगाहर्ट्ज यहाँ पे, और यहाँ पे 5 मेगाहर्ट्ज. सो 5 मेगाहर्ट्ज का आपका लोअर साइड बैंड है 5. So the only thing which is explained over here is nothing but your modulating frequency for your video is 5 megahertz. ठीक है, this is for video. That's why your FM upper sideband FC क्या है, 0 है ये केस में आपका. So 0 plus 5 and 0 minus 5. Where you are going to put your sound carrier? Your sound carrier must be 5.5 megahertz away from your picture carrier. तो आपका अभी sound carrier कहाँ पे है? 5.5 megahertz away. So it's 5.5. So and then if you're putting your sound carrier over here 5.5 megahertz, you're not supposed to like uh, cut your channel over there. You need to give some guard band. अगर आप दूसरा चैनल यही से स्टार्ट करेंगे तो आपका क्या हो जाएगा, यहाँ पे इंटरमिक्सिंग जो भी कॉर्नर्स पे आपकी इंफॉर्मेशन है इस फ्रिक्वेंसी पे, इट विल गेट mixed with other channel information. So you need to keep a 0.25 का guard band. So what will be the total channel requirement? See 5.5 यहाँ पे, 5.5 यहाँ पे, you can't, sorry 5.5 यहाँ पे, so total 11 megahertz. So total bandwidth you need is nothing but the आपका जो भी है वो 11 मेगाहर्ट्ज, क्योंकि 5.5 आप you can't cut your channel. You might have gone through the responses of various filters, responses of various channels. आपका attenuation slope होता है उसमें, ठीक है, immediately वो information वहाँ पे. So you need to consider that attenuation slope which is 0.5. So 5.5 plus 5.5 11 megahertz, plus you need to give some guard band between two channels. So this is the requirement of a one channel. So what is my one channel requirement? It's 11.25 megahertz. ठीक है. So if I need a 11.25 megahertz of like bandwidth, it's a huge bandwidth. If I want to transmit 100 channels, अगर मुझे 100 channels transmit करने हैं तो मुझे इसमें 100 multiply करना पड़ेगा. और if I calculate the total requirement, it will be 1.125 gigahertz, which is very high. ठीक है. So what we have already studied, your upper sideband and your lower sideband contains the same information. ठीक है. In the amplitude modulation, this information whatever is there in the upper sideband will be same as your lower sideband. So if we transmit only one sideband, that will be sufficient in this case. But and this kind of a transmission is called as a single sideband transmission. ठीक है, SSB. But what is the drawback of this particular SSB transmission? Now as we know, in the communication field or in the communication area, always the signals which are having a lower frequency contains a high information. ठीक है. So I think I have given you one example, whereas we consider that जो more occurrence होता है having a high frequency and less information. So whatever frequencies, whatever lower frequency information is there, it is very important. And if you are not able to design a filter which can filter out that much band only, then it will affect your lower frequency information. See, dog bites man, the frequency is more, so you are having a very less information. Man bites a dog, it is having a very rare occurrence. So the information which is having a less occurrence contains more information. That's why to save my low frequency, instead of cutting the complete lower sideband, आप एक sideband के साथ भी भेज सकते हो. ठीक है, this is called as a single sideband transmission. So instead of, it's very difficult to generate the single sideband transmission. You might have studied it in your analog communication or communication theory, that SSB generation or detection, it's very difficult kind of things. And that's why instead of using SSB, what we are doing, we are just taking a vestige, or you can say a very small part of the lower sideband instead of cutting the complete lower sideband. दोनों इन्फॉर्मेशन सेम है, लेकिन टू सेव माई लोअर फ्रीक्वेंसी इन्फॉर्मेशन, आई एम नॉट कटिंग द कंप्लीट लोअर साइड बैंड, आई एम टेकिंग जस्ट द पार्ट ऑफ लोअर साइड बैंड. ठीक है. And that part which I am taking is nothing, and now this kind of a transmission will be called as the vestigial sideband transmission. ठीक है. सो अगर आप यहाँ पे थोड़ा सा पार्ट LSB का निकालेंगे और थोड़ा सा लो फ्रीक्वेंसी वाला भेज देंगे, तो this kind of transmission will be called as the vestigial sideband transmission. So here you can see a part of LSB is removed. How much part you are taking from the lower sideband? 0.75, and you need to give a 0.5 का attenuation band. तो आपके upper sideband में क्या है? So total bandwidth here, now this is the system which we are using in our country, and this system is called as the PAL, that is phase alteration by line. American TV standards and French TV standards are having a different values. So here if I talk about the bandwidth, I have 5 megahertz of a video signal, 0.5 is attenuation band, ठीक है, 0.25 is guard band, और यहाँ लोअर का 0.75. यहाँ पे आपने 0.75 फ्रीक्वेंसी लिया है, लेकिन आपको यहाँ पे उसका ये बैंड रखना पड़ेगा, दैट इज अटेन्यूएशन बैंड, विच इज नथिंग बट द 0.5. So this collectively becomes 1.25. So if I add all this 5.5, ठीक है, plus 5, it becomes 6. 6 plus this 1, this become a 7 megahertz. Now previously my channel bandwidth requirement was 11.25 megahertz, and if I'm going for a vestigial sideband transmission, I need a total channel width as a 7 megahertz. ठीक है. And this is what we are doing. We are taking a vestige of a lower sideband here. So now transmission efficiency, I think I have already given you how we calculate the total power. Total power is the carrier power, upper sideband power plus lower sideband power, which is nothing but the EC square by 2R, because we are considering RMS voltage of your carrier signal, or RMS value. So M square EC square by 8R plus M square EC square by 8R. If you put it in terms of the PC, I can say M square EC square by 2 is nothing but the by 2R is nothing but the carrier power. So I'm just putting, so PC 1 plus M square by 4, PC plus M square by 4 PC, which is nothing but the PC 1 plus M square by 2. So if I'm interested in calculating the transmission efficiency, so if I remove this particular sideband, मैंने अभी क्या किया, carrier frequency, or I have transmitted, I can say, um, uh, vestige of lower sideband and a complete upper sideband. And if I'm considering that my modulation index is 1 in this case, so what will be the total power? I can say it's PC 1 plus 1 by 2. So my total power is 1.5 of carrier power. ठीक है. So आपका जो भी total power होता है, so you can say your two sidebands has a maximum value of 50% of the carrier power. So it is clear that the carrier component, that is redundant. So as far as transmission or intelligence is concerned, you can save 70% of the total power if you're going for the vestigial sideband transmission. ठीक है. आप यहाँ पे, and you can increase the transmission efficiency also here. So transmission efficiency is nothing but the, you can say, total power saved divided by total power required. So here if I'm going to use only a vestige of a lower sideband and a complete upper sideband, my power will be saved in this case. Okay. So this is all about why we are going for the vestigial sideband transmission. Now we'll talk about complete channel bandwidth. ठीक है. Now here I'm just talking, now here three systems I'm going to discuss. The first system is nothing but the European or Indian system, which is called as a PAL. Another system which I'm going to consider, it is nothing but the NTSC, which we call as American. And then third I'm going to talk is nothing but the CKM, that is French system. So first I'm going to talk about the Indian or European TV channel sideband spectrums. So you are taking complete upper sideband, 0.75 of a lower sideband, attenuation band 0.5 का तो 1.25. So and you are just putting your sound carrier at 5.5 megahertz away from your picture carrier, ठीक है, and 200 kilohertz का bandwidth दिया जाता है यहाँ पे. So if I add all these things, my complete, this is 5.75, ठीक है, and this is 1.25. So complete channel bandwidth here which I'm using for Indian or European system is 7 megahertz. Then I'm going for the UK TV channel standards. So in the UK TV channel standards you are having a video signal. आपका जो भी वीडियो सिग्नल है वो 5.5 तक है, ठीक है. तो आप यहाँ पे यू आर जस्ट putting your sound carrier at 6 megahertz and you are giving some of the guard band that is 6.25, ठीक है. So यहाँ पे 6.25, यहाँ पे 1.25, ठीक है. So sorry, this is the French system. UK TV system means a CCAM system. So total channel bandwidth will be 1.25 plus this attenuation band of 0.5 becomes 1.75 plus 6 point. So अगर आप पूरा चैनल बैंडविड्थ यहाँ पे देखेंगे तो ये हो जाएगा 8 मेगाहर्ट्ज. सो यूके टीवी स्टैंडर्ड इज हैविंग अ 8 मेगाहर्ट्ज का चैनल बैंडविड्थ और आपका कलर सब कैरियर इज एट 4.433 मेगाहर्ट्ज, ठीक है. Now this thing I am going to explain afterwards. Next one is nothing but the American TV channel standard. So this is nothing but the you can refer this particular system as a NTSC. So आपका लोअर वाला 1.25 ही है, ठीक है. अपर वाला आपका जो वीडियो है अप टू 4 मेगाहर्ट्ज. Your sound carrier is at 4.5 megahertz. So with attenuation band you are having, or with guard band and attenuation band, 4.75 plus 1.25. So in American system your bandwidth is 6 megahertz, ठीक है. Indian system 7 megahertz, American 6 megahertz, and UK, that is French system, is having a 8 megahertz of a bandwidth. So this is how your in the you can say Indian system 5 megahertz का वीडियो बैंडविड्थ है, अमेरिकन में 4 megahertz का वीडियो बैंडविड्थ है, और अगर यूके स्टैंडर्ड्स में आप देखेंगे तो यू आर हैविंग अ 5.5 मेगाहर्ट्ज का वीडियो बैंडविड्थ, ठीक है. सो दिस इज द डिफरेंस. एंड देन वेस्टेज of American and Indian TV are same, but for UK system it's bit more. Now the channel allocation. So how you are allocating the channel? So if I'm taking the example of band 1 channel 3, band 1 की हम लोगों ने देखे, आपका फर्स्ट चैनल होता है 41 से 47, देन 47 से 54, तीसरा चैनल होता है आपका 54 से you are having it up to at 61. So are you going to transmit your picture carrier immediately at 54? No, it's 1.25 away from your start of the. So this is 54 plus 1.25. So आपका picture carrier यहाँ पे होगा 50.25 megahertz पे. So similarly you can see here your picture carrier is at 55.25 megahertz, ठीक है. The next one is nothing but the you are having a sound carrier 5.5 megahertz away from the picture carrier. Once I understand what is my sound carrier, I can write here picture carrier. So this is 5.5 addition. So this becomes a 61.7 sorry 75. So अगर आप यहाँ पे देखेंगे is it 61, oh sorry it's 60.75, ठीक है. So यहाँ पे आपका साउंड कैरियर आपका 0.25 गार्ड बैंड दोनों चैनल के बीच में है, तो 61 पे दूसरा चैनल होगा. 61 में वापस से 1.25 ऐड करिए आपका पिक्चर कैरियर, उसमें 5.5 ऐड करिए उसमें. सो आई टोल्ड यू दैट विल गो टू दैट पर्टिकुलर स्लाइड यहाँ पे, ठीक है. Okay, fine. So that thing on the slide 3 I'll explain you once again what is there. Go to का option यहाँ पे screen. Okay, so if you see here I have already given you these things, ठीक है. So 47 पे आपका 48.25 पे है, 53.75 पे है, again 61 to 60. So similarly your picture carrier is 1.25 plus this starting point, and your sound carrier will be 5.5 addition in this particular, ठीक है. So this is all about what we have seen, ठीक है. The next one is nothing but the I think we have already talked about the चैनल अलोकेशन, ठीक है, एडजेसेंट चैनल्स कैसे होते हैं। नाउ बेसिक एफएम मॉड्यूलेशन वेवफॉर्म, आपका मॉड्यूलेशन, वी हैव टॉक्ड अबाउट द एम्पलीट्यूड मॉड्यूलेशन, नाउ विल टॉक अबाउट द फ्रीक्वेंसी मॉड्यूलेशन, ठीक है। सो ये आपका मॉड्यूलेटिंग सिग्नल है, ये आपका frequency modulated signal है, ठीक है। now this frequency versus time in the fm, what is the maximum deviation, here you are getting carrier frequency plus some frequency, you are getting carrier frequency minus, so normally आपका जो भी carrier signal होता है वो maximum deviation, और it will have a maximum deviation when it is the highest point and maximum deviation when it is at a lowest point, यहाँ पे और यहाँ पे आपको यहाँ पे ज्यादा frequency मिलेगा, यहाँ पे कम, so that is the change in your frequency, that is what we called as the plus minus delta f. So here, how, what is the maximum allowed deviation here, your maximum allowed deviation is nothing but the 50 kilohertz, ठीक है। how we calculate the bandwidth in fm channel, it's 2 n fm, fm is the frequency of modulating wave, though we are talking that our frequency is from 20 hertz, 20 hertz to 20 kilohertz, our ऑडियो सिग्नल डज नॉट एक्सेड मोर देन 15 किलोहर्ट्ज, ठीक है। और एन क्या होता है, एन इज नथिंग बट द नंबर ऑफ सिग्निफिकेंट फ्रीक्वेंसी और number of side bands, as in the amplitude modulation you are having only two side bands, but in the frequency modulation you will, your sidebands will depend on the modulation index. And what is the modulation index, modulation index is given by the formula delta f divided by fm. So if I'm talking about the modulation index, it will be delta f divided by fm. What is delta f, maximum allowed deviation 50 kilohertz, and what is the maximum frequency, that is 15 kilohertz, and it comes 3. And for modulation index 3, if you see the Bessel's function, in that Bessel's functions you will observe that modulation index 3 के लिए आपके significant side bands होते हैं 5. So you put that value 2 into 5 into fm, that is 15. So what will be the bandwidth, 150 kilohertz. Otherwise you, if you are having a modulation index more than 6, you can use a Carlson rule also, that is 2 into delta f plus fm, ठीक है। So we are just sticking because we don't have that particular modulation index more than 5 or more than 6, so our bandwidth is 150 kilohertz, ठीक है। आपने रखा कहाँ पे उसको, 5.5 megahertz away from the picture carrier, bandwidth is 150 kilohertz, ठीक है। so plus 75 वहाँ पे, minus 75 यहाँ पे will be okay. So you can say that you, if you are having this particular 5.5 megahertz पे साउंड कैरियर, आप यहाँ पे 150 को डिवाइड किया है, 150 को डिवाइड 150 किलो हर्ट्ज में है, तो अगर मेगा हर्ट्ज में जाएंगे तो 0.75 हो जाएगा। सो यू कैन से दिस इज द अलाउड बैंडविड्थ फॉर साउंड कैरियर 200 किलो हर्ट्ज, ठीक है। सो चैनल बैंडविड्थ कलर ट्रांसमिशन के लिए you are allowing the same bandwidth, or you need to give the same frequency as it मस्ट ऑक्यूपाई इन द सेम बैंडविड्थ, वो उसी बैंडविड्थ में जाना चाहिए, ठीक है। सो अगर हम यहाँ पे चैनल बैंडविड्थ देखेंगे कलर ट्रांसमिशन के लिए, योर पाल सिस्टम, आई एम टॉकिंग अबाउट इंडियन सिस्टम now which is compatible with the CCIR 625 line monochrome system, your color subcarrier is located at 4.43 megahertz away from the picture carrier. Why only 4.43 megahertz away from the picture carrier? Now, this concept is called as the frequency interleaving. So, whenever I'm talking about a frequency interleaving, see what is your line frequency or horizontal scanning frequency, 15625. Okay, while transmitting, you will have now your composition of video information is at multiple of the line frequency. So, FH, twice FH, thrice FH, and so on. Okay, up to 5 megahertz, ठीक है। now here if I try to put my color subcarrier somewhere here, my line frequency is very high or its amplitude is very high, so it may hamper my intensity information. When I say line frequency, it's nothing but the intensity information or the brightness information, so brightness पे वो affect करेगा। now I need to interleave my color subcarrier somewhere here, इसके बीच में, तो वो अफेक्ट नहीं करेगा। लेकिन आई कांट लीव माई इंटरलीव माई कलर सब कैरियर हियर, क्योंकि मेरे पास ऑलरेडी बहुत ज्यादा एम्पलीट्यूड के लाइन और ब्राइटनेस इंफॉर्मेशन यहाँ पे है। सो बाय ऑब्जर्वेशन इट इज ऑब्जर्व्ड दैट योर this line frequency or this brightness information is having the less value at this particular point, ठीक है। आपका 283.5 पे उसका इंफॉर्मेशन कम है, ठीक है। सो the energy content progressively decreases with the increase in the order of harmonics, and it is very small beyond 3.5 megahertz, ठीक है। Means where you there you can leave your color subcarrier, that is 283.5 fH. So if I calculate this 283.5 fH, that is 283.5 into FH is 15625. So this frequency comes 4.43 megahertz. So this will not affect the contents of my brightness information. So, and as this particular amplitude is lower, it will not hamper my color information. And this concept is called as frequency interleaving. So you can see chrominance information falls between Y signal harmonic. It is not at the Y signal, that is luminance पे वो ओवरलैप नहीं कर रहा है, वो luminance के बीच में है। और आपने कहाँ पे इंटरल्यू किया है, जहाँ पे आपका luminance सिग्नल ड्रास्टिकली फॉल हो रहा है उसका एम्पलीट्यूड, ठीक है। सो दिस कंसेप्ट इज कॉल्ड एज अ फ्रीक्वेंसी इंटरलिविंग। सो यू कैन सी in order to avoid crosstalk with the picture signal, the frequency of the subcarrier is chosen कहाँ पे, एट यू कैन से 2 into 283 प्लस 1 15625/2 4.43 मेगा, जैसे मैंने आपको कैलकुलेट किया है। सो दिस इज ऑल अबाउट योर चैनल बैंड सिग्नल ट्रांसमिशन एंड चैनल बैंडविड्थ। विल स्टॉप हियर, थैंक यू।